All right, so ladies and gentlemen, this is day 2 of chapter 9.1. So as we take a look, we're graphing these things again using that same formula. So we've talked about this guy already. Basic quadratic equation, y equals ax squared plus bx plus c. And this, guys, is just basically saying, hey, if you want the x value of your vertex, figure out what that axis of symmetry is. Sorry about that. So the big idea is if you want to find that vertex, then we use that axis of symmetry. We call that the AOS, axis of symmetry. That's the line that cuts our guy in half. We talked about that's x equals negative b over 2a. Are you serious? Really? Oh. Maybe he's using his calculator. Your calculator's a good number. Okay. Colton, do you need something, buddy? No? You're good? Oh, got it. Thanks. Bears. All right. So there is our axis of symmetry formula, just like we've been doing, right? Plug that guy in. Oh, my gum fell off. Oh, plug that guy in, and then we get our y value. Okay, so that's what that f of negative b over 2a, that's just fancy notation for function notation. Okay, so don't let that scare you. All right, so example 1, it says find the coordinates of your vertex using that x equals negative b over 2a, and then graph it. State the domain and range. So here we go, so we can see it. All right, so I've got y equals negative 6 plus 1. Let's do these two pretty equations here. A, what's A? What's the number in front of x squared? Griff gives me the finger, the index finger, number 1. And then B, we got what? Negative 6. And now we got x equals negative b over 2a. Guys, that will be given to you at quiz or test. You don't need to memorize it. That's our axis of symmetry. So we plug in. I got the opposite of negative 6, and then 2 times 1. What's the opposite of negative 6? 6. And 2 times 1 we know is 2. So we get x equals 2. So far, so good? Yep. That's what I said. That's what I said. I was just seeing if you're listening. So I got x equals 3. Thank you. I got 6 divided by 2 is 3. Mr. Gotsch. 1, 2, 3. Look on your x-axis and find 3, and then make a vertical line on that guy. And then go ahead and label it. And now we got to find the vertex somewhere on that line. That vertex is 3 comma something. How do I find the something? Boom. Yeah, so go up to that equation up here. You know the x value. Now just plug it in and find the y value. Okay, so I'll go off to the side here. If you like using a table, you can use that table. Keep it organized. Here's 3. And now I'm going to do 3 squared minus 6 times 3 and then plus 1. Okay. I usually just do that in my head, and I'll go, okay, what's 3 squared? 9. What's negative 6 times 3? Negative 18, and then plus 1. And then we simplify, and what do we get? What's 9 minus 18? Kai, what do you end up with? Negative 8. Does that be okay with that? Right? So 9 minus 18 is negative 9, and then plus 1 is negative 8. So there's my vertex. You guys can also do that in the calculator too, right? If you really need the calc, go ahead and use it. Just make sure when you square any negative numbers, you get a positive. So I count down 1, 2, 3, 4, 5, 6, 7, 8. And there's my vertex at the very bottom of this graph. Okay. So far, so good? Now, eventually, you guys are going to get to the point where you can start seeing a pattern here with quadratics. The pattern is, if I go over 1, what's 1 squared? 1. So I would go up 1, over 1, up 1. Now, if you don't like that idea, make a table. The next integer to 3 is what, 2? So plug in 2. So what I'll do is I'll take that equation and I'll plug in 2 up here, and I'll say, okay, what's 2 squared? That's 4. What is negative 6 times 2? It's negative 6 times 2, negative 12, and then plus the 1. And I simplify. 4 minus 12 is negative 8, and negative 8 plus 1 is negative 7. And that's what the point I have here is over 2 and down 7 is this guy right here. That follows that pattern, over 1, up 1, over 1, up 1. Now, from the vertex, if I count over 1, 2, what's 2 squared? Because it's a quadratic. 4. So I'd go over 2 and up 1, 2, 3, 4. Over 2, 1, 2, and up 1, 2, 3, 4. Now that gives me my nice, pretty quadratic. I do ask that you get at least 3 points, the vertex, and at least 1 on the left and 1 on the right. If you can give me 5, even better. Now, if you're using a table, the next integer would have been 1. And you can go through and say, okay, what's 1 squared? 1 squared is 1. Negative 6 times 1 is negative 6, and then plus 1. 1 minus 6 plus 1 is what? Negative 4. And if you look, over 1, down 1, 2, 3, 4 is that point right there. Okay, so you guys have a few different ways now to come up with some additional points. Once you have the vertex, you got to get the vertex first, right? That's the baseline. That's where this thing all starts. Okay. Once I have that vertex, now I have a pretty good idea on what this is looking like. Okay. Now, understand that that pattern only works, though, if the A value is 1. So if the A value is 1, over 1, up 1, over 2, up 4. If the A value is 1. 1. Okay. Eventually, we talked about if the A value is negative, then it gets flipped. So if it's a negative 1, it would go over 1, down 1, over 2, down 4, because it's a frowning face. Okay? All right. Domain and range. Domain is always, from left to right, negative infinity to infinity. Or if you like the fancy R, range is bottoms up. How low does it go? Damien? So this one from the left, it goes to negative infinity. It just keeps going and going to the left, never stops. So negative infinity. And from the right, it goes to positive infinity. So left to right, the x values being used is every x value you can think of. Okay. Infinities always get parentheses. Always, always, always. Okay. So always parentheses there. Or you can do the fancy R, which means all real numbers. Does that answer your question? Okay. Now, when we look at range, we look to see how low it goes. How low does it go? Does it go down low, down to the flow? Where is it? Okay. Huh? Yeah, it starts at -8, doesn't it? So bottoms up, it starts at -8, and that, Damien, is a bracket. That is a part of the graph. It's inclusive, so we got to make sure that's a bracket. And then we ask ourselves, how high does it go? Does it go up high all the way to the sky? Yep, it sure does. It goes all the way up to infinity. Okay. Again, a reminder, your vertex, that y value, that's going to be part of your range. Okay. All right, questions? All right, do you want to do 2 or 3? I want to do one more for today. Let you guys have some time to work. 2 or 3? 3? All right, let's do 3 real quick. So we're flipping on over to number 3 for all you playing at home. So we're skipping 2. All right, I've got y equals, I got x squared plus 2x. Hey, what's a? 1. What's b? 2. I use that formula, negative b over 2a. So that's negative what? Negative 2 over 2 times what? 1. That's negative 2 over 2, which we know is negative 1. I think that's what I heard Colton say earlier, right? That's your axis of symmetry. That cuts your graph right in half. So I'm going to count over to negative 1 on the x-axis, and I'm going to make that nice, pretty axis of symmetry. And I always like to label it so I can see it. Okay. All right, well, now we got to find the y value. We got to plug it in, plug it in. You got to plug that negative 1 in. If you want to use a table, you should be able to use a table. Helps you guys visualize what's going on. Go ahead and take negative 1 and square it. I'll write this one out for the vertex so you can see it. If I plug in negative 1 and square, make sure you put parentheses if you're using your calculator. And then I've got 2 times negative 1. What is negative 1 squared? What is 1? Negative 1 times negative 1. Ivan's given me the finger. 1. The index finger. 2 times negative 1 is negative 2. What's 1 minus 2? Negative 1. Is okay with that? So I'm going to go ahead and graph over 1, down 1 from the origin right there. What's the next integer that I could plug in? What's the next one to the right of negative 1? 0 or negative 2, either one, doesn't matter. I usually try to go towards the origin so I can maybe plug in 0. Plug it in. What's 0 squared? 0. What's 2 times 0? 0, and 0 plus 0 is 0. So now I got this point here. Dun, 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 dun. It's symmetric. Same thing happens if you plug in negative 2, you'll get 0. Okay. That's the bare minimum, guys. Those are the 3 points I need. Now, it makes it a little bit nicer if you can give me 2 more points, 1 on each side. Give me 1 more integer I can plug in. What's to the right of 0? 1, so plug in 1. What's 1 squared? 1 plus 2 times 1. What's 2 times 1? 2. 1 plus 2 is 3. So I'm going to graph 1, 3. So that's over 1 up, 1, 2, 3 from the origin. It's symmetric. Okay? Now, the other way I do it is once I have my vertex and I know I have an A value of 1, I'll just follow the pattern. Over 1 up 1 from the vertex, over 2 up 4. 1, 2, 3, 4. Perfect. All right, so we have our vertex, -1, -1. I got my domain. What's my domain? What do you got? Rylan, what's the domain? Always, always, always. Perfect. And then the range is bottoms up. How low does it go? Where does it start at? Audrey, what does it start at? -1, and it goes all the way up. It's inclusive at -1. It's a solid dot there, right there. Goes all the way up. Again, we're getting that -1 from the vertex, from that y value. Okay. Ladies and gentlemen, that's it for today.